Okay, we're going to start talking about solving multi-step equations. And this is actually going to be two different videos, so this is part one. And before we get started with the multi-step equations, we need to talk about solving with two terms in the numerator. And this goes back to some of your solving multi or two-step equations that we did in the last video. Normally, when we were looking at our two-step equations, I'm just going to give you an example of a two-step equation. X over 5 plus 2 equals 10. Plus sign kind of mixed there with my fraction bar, but when you look at this equation, there is one term in the numerator. That's our x. I'm going to put one term. It's kind of sloppy writing there, but one term in the numerator. What we're going to look at in solving that equation, you all should know how to solve that. This is what we did in the last video. You would subtract 2 from both sides, and then because you're dividing by 10 in this problem originally, dividing by 5, originally we're going to multiply both sides by 5 after subtracting the 2. So if you're solving that equation, you should get x is 40. But what I want to look at is the difference in this type of equation and one with two terms in the numerator. So we're going to look at this one. X minus 7 over 3 equals negative 12. And as you notice, x minus 7 there in my numerator, there are two terms. X and a negative 7. So that makes the subtraction problem x minus 7. So what we've been discussing with our two-step equations is that we could take the order of operations and go in reverse. So on this first one here that I wrote, we would, instead of multiply and then addition, which is typical order of operations, we would actually take care of the addition and then the multiplication. We would work backwards. When you have a fraction bar, which is also considered a grouping symbol, but when you have a more than one term on the top. So in this case we have two terms on the top. So when you have some type of algebraic expression on the top of your numerator, I can't start adding 7 to both sides of my equation like I would in something similar to this. The reason is this minus 7 here, not only is it attached to the x, okay, not only is this a subtraction problem, but it's part of the numerator. And I can't just start manipulating the numerator without considering the denominator at the same time. So what's best to do in this type of problem is just eliminate the denominator altogether. Now, this is your fraction bar. This is also considered the division sign, or an example of a division sign. So rather than dividing by 3, if we want to move this to the other side, we're going to multiply both sides by 3. So fairly simple. Just multiply both sides by 3. And we've discussed when you are multiplying and dividing, this gives you 1. So that leaves us with just our numerator, which was the goal there. X minus 7 equals, and on the other side we have negative 12 times 3, which gives us negative 36. So what we did there is we just multiplied both sides by the denominator, which was 3, in order to eliminate that denominator, so that we're just left with our expression x minus 7, just left with our numerator. So now it's just a simple one-step equation. The inverse of negative 7 or minus 7 is to add 7 to both sides. So when you add 7 to both sides there, you get 0 on the left-hand side, which is what you were going for. X equals, and then negative 36 plus 7 is negative 29. So just being able to solve equations, and this, again, this was just a two-step equation, but because it had the expression in the numerator, we had to handle it just a little bit differently than some of the others. Okay? So we're going to move on and look at multi-step equations now. And in order to solve multi-step equations, we've got to think about all the properties we've discussed so far. We've got the properties of equality, which are if you add a number to one side, you have to add a number to the other side of the equal sign. So keeping the equation balanced on either side of the equal sign. Then also we have our inverse operations, which we've discussed, where the opposite or the inverse of addition is to subtract, multiplying is division. And then we also have our properties of real numbers. We may have to use commutative or associative property in order to change the order or change the grouping. We may use the distributive property. Any types of the properties of real numbers that you've used, we may have to use those when solving equations. So you have to use all of these properties in order to isolate your variable, which is the end goal for solving equations, to get the variable by itself on one side of the equal sign in order to have your solution. So, first thing that I want us to look at, just a simple multi-step equation here. So, first example, 8x plus 5 minus 6x equals 25. So hopefully, because you've looked at combining like terms already up to this point, hopefully this kind of sticks out in your mind that you do have like terms here. And one misconception that we have, because with equations, what we do to one side, we always do the other, and that sort of thing, we get into inverse operations and people start getting a little confused. One thing you need to pay very close attention to is that your like terms, the 8x, and we carry the sign that's in front of it, the negative 6x, are on the same side of that equal sign. They're not on opposite sides. So I don't have to move one over to the other. What I can use is a property of real numbers. Hopefully you're thinking about what property this is. We're talking about the commutative property, which means we can change the order of our terms. So I could make this 8x minus 6x plus 5 equals 25. Making sure I carried the signs with the number that it's in front of. And so then you can see you've got your like terms here side by side. And so if you subtract 8x and 6x, 8 minus 6, you would have 2 x's. Whoops. Need to use pen. You would have 2 x's, and then still your plus 5 equals 25. Now some people skip this step here, which is fine. If you put a box or underline or whatever you need to do to identify your like terms, and then you should see 8x minus 6x, which again gives you 2x. But this is using the correct properties of real numbers here to change the order of your equation. Now you're down to a two-step equation, just like we had in the previous video. So the inverse operation of adding 5 would be to subtract 5, and then since we are moving this over to the other side of the equal sign, you have to make sure that you subtract 5 from 25, which gives us 2x, because this is 0, equals 20. I'm going to rewrite my problem up here, 2x equals 20. And that 2 is right next to the x, so that should automatically indicate to you that this is our multiplication. So the inverse of multiplication is division. So divide both sides by 2, and you get 1x equals 10. So multi-step equation, very simple multi-step equation, but that's what we have there. So I want you all to try one. So here's your equation to try. 11m minus 8 minus 6m equals 22. So go ahead and pause the video, take a minute or so to solve that for m, and then come back to check your answer. Okay, hopefully you have paused the video and you're now coming back to check your work here on this problem. This is 11m, and its like term is negative 6m. You can change the order of this equation if you would like in order to see those two yellow boxes side by side so that you're like terms are side by side, or you could go ahead and subtract these. That's fine, either way you want to write that. But you will have 11m minus 6m, which should give you 5m, then minus 8 equals 22. So hopefully that first step of combining like terms was pretty simple, and now you're down to a two-step equation. The inverse of subtracting 8 is to add 8, making sure to add 8 on both sides of my equal sign. So this gives me 0. I'm left with 5m equals 30. Then the opposite or the inverse operation of multiplying by 5 there is to divide both sides by 5. So m equals, make sure you divide 30 by 5. Just to kind of throw this in there as a side note, some people divide upside down. They divide 5 by 30. So be very careful. You should divide exactly the way you see it from top to bottom. 30 divided by 5, and you should have gotten 6. So just a little side note there. Be very careful how you type that in your calculator if you need to type that in. Now, one thing that I want to go over with this problem, now that you have the correct answer, is when I was telling you that we have to move things from one side to the other and that sort of thing, equals 22. What you have to be careful of, and what happens to some people, is they see these two expressions, these two terms, and because they're so used to doing the opposite operation and they're moving from one side to the other, rather than doing 11m minus 6m, they will oftentimes add 6m to what they believe is both sides. But notice I have not, if this is my divider here, my equal sign is my divider, I've added 6m to the same side twice rather than adding from one side to the other. So this is a big no. Okay, do not do that. If you are collecting like terms, you just simply add or subtract them together. The only time you do the opposite or inverse operation is if you are trying to move something from one side of your equal sign over to the other side. So always be very, very careful when you do that. Okay? Alright, the next video for solving multi-step equations will involve some word problems and some more difficult problems to look at dealing with distributive property and other types of properties for your equations. So your summary for multi-step equations will not come until the end of the second video. So make sure now you understand these examples. Go to the textbook if you need to look at any other further examples of using the properties to solve multi-step equations, and then move on to multi-step equations part 2.